job in this lesson is to label graphs of polynomials. We're going to go over and identify critical attributes of the graph of a polynomial. So polynomials were those functions where we had like x to the third plus 2x squared plus 4 or something like that. So we've seen polynomials before. We're just going to take a look at the graphs now. Okay. First off, let's start with function degrees and how you can tell what kind of functions you're going to have. All of these degrees and the types are all based off of how many times your function is moving towards the top of the graph and how many times it is moving towards the bottom of the graph. You always read graphs from left to right. So we start over here and we follow the line or the curve, whatever it is. This graph is always moving up. That is one direction. I'm going to draw a little arrow to show that the graph is moving up. Since it is moving in one direction, that means that we have the function degree of x to the first power. Okay, the 1 is because the graph is moving in one direction. The word that we're going to use for that is linear. Okay, so anytime we had a 1 as an exponent, the function type or classifying the function based on degree is the word linear. Okay, next one. We start on the left and move towards the right. Every time we start moving up or down, we switch and draw a new arrow. So here we are drawing down first. And then we keep going, going, going. Then we have this spot right here where we switch from moving down to moving up. These words are called decreasing and increasing. We'll get into those a little bit more later. So moving down and then moving up. So we have two directions, down, up. That means our function degree is 2. We would have an x squared. This is also called second degree. The type of problem we have is a quadratic. We have seen quadratics quite a bit before, especially with factoring and with a quadratic formula. This is like super duper common. This picture is called a parabola from that shape. Let's take a look at the next graph. Start from the left, move your way as we go towards the right. As we move towards the right, we are moving up. Then we switch from moving up to starting to move down. And then we move from down to up. That is 1, 2, 3 directions, so it is a third degree polynomial of some sort. So x to the third power, we call that a cubic function. Right, we would say x cubed, so it's cubic. Last one over here is kind of a W. This would also work for an M-shaped graph, like if you rotate this upside down. Start at the left and work your way towards the right. Just trace, trace, trace. So as we work our way towards the right, we are moving down first. And then starting here, we start to move up. And then we get to here and start to move down. And then we get to here and start to move up. There are 1, 2, 3, 4 directions, so this is an x to the fourth graph. There's a fancy word for x to the fourth. It is called quartic. Okay, so quart, like there are 4 quarts in a gallon of milk. There are 4 quarters in $1. There's 4 quarters in a basketball game or a football game or whatever. All right, so important information. Okay, let's move on down to the next set of information. And I'm going to cover stuff up just so I can talk about it kind of at the right time, even though you may have already filled it out. I'm not worried. All right, minimum and maximum. Minimum means the lowest point in that area, the low point or the bottom of a curve. And I got a little smudged, low point. So in a picture, what that would look like is this. This guy right here would be a minimum. Technically, the y value itself is the minimum, but we usually also want to know what the x value is at that minimum as well. So we generally want to see the point, the x comma y point. For a maximum, also called a max, that is the high point, and it happens at the top of a curve. So you'll see a curve that looks like this, and then a maximum is way up there. Over here for zeros, we've done zeros quite a bit. We have factored and set each factor equal to 0 and solved for x. That's a way that we have found zeros with polynomials. including with quadratic functions. We've used the quadratic formula. So those things are all zeros. Zeros are your place or places where your graph crosses the x-axis. Let's draw a little picture of that. On x-axis, I'm going to put a y-axis just kind of because we usually see one. And then I'm going to draw, let's draw a cubic function, 1, 2, 3 directions. That's how I got cubic, like this guy. This graph crosses the x-axis 1, 2, 3 times. So I'm just going to make those little x-intercepts or zeros or solutions, lots of words. Just make those like more pronounced points, I guess. Okay. In previous problems, we have written the x-intercepts as answers like x equals a number. We're still going to have that. X equals, and then you put whatever the number is where your graph touches the x-axis. It doesn't have to cross, it at least just has to touch. So you might want to add the word touch in there if you choose. Touches or crosses the x-axis. Next, end behavior. This is usually everybody's favorite, end behavior. We use the words rising or falling. So if the end of your graph is going towards the top of a grid, you use the word rising. If the end of your graph, like the arrow, is pointing towards the bottom of the grid, then your end behavior is falling. So for example, the left side, L-E-F-T, might look like this for rising. The right side would look like this for rising. And over here, for falling, the left side would look like this, and the right side would look like this. Usually this is a favorite of students because you just get to look at the ends and you don't have to do any real work involved. So it's just like, is it literally pointed up or down? Okay, let's take a look at our 3 examples. Before we get started, I'm going to add arrows to the tops and bottoms. So like any ends, I'm going to put arrows. Makes it a little bit more obvious that the graph goes on forever. But generally, like we've seen lots and lots of graphs, and on those graphs, the picture is always cropped, so you can't really see most of the ends. Go ahead and zoom out so you can see what's up. So I'm putting arrows, arrows, and then arrows down here. That's really going to help us with our rising and falling. I also labeled the X and Y axes. If yours are not labeled, go ahead and do so. I also just kind of traced along the X and Y axes to make them a little bit darker. I know sometimes, especially like on this first problem, the X axis wasn't super dark, but we know the X axis should touch the Y axis at 0. So if you notice, this is 6, this is, looks like 5, 4, 3, 2, 1, 0. So it should be here, and then -1, -2. Okay, so if your graphs are not super clear, you can use the numbers that are on the grids to help you out. Okay, we have lots of questions. They're very, very quick to answer. First off, type and degree. So we look for where our graph is moving up and moving down. I'm going to go with blue because that's what we used up at the top of the page. So we start at the left and trace our way towards the right. So as we trace, we are moving down first. That's one direction. Then we switch and we start to move up. And then we switch and we start to move down. That is 3 directions, down, up, down. So our degree is 3, which makes this a cubic function. Okay, second thing, zeros is the next thing it asks for. This is where our graph touches or crosses the x-axis. So let's find that x-axis right here. Looks like our graph, which is the picture, crosses at one spot exactly, right here. And we were told that for zeros, our answer is going to look like x equals a number. We just picked the exact number that's right there, which is x equals 3. That's all you got to put for that. Next are min and max. Min and max are the low point and the high point of a curve. It's not where the arrows are, it's where the bottom of a curve or the top of a curve is. So let's find those. Okay, as we follow down, 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 we get to the bottom of a curve that's right here. And that is the point 0, 1. 0, 1. Since it's at the bottom of a curve, it's the minimum. Okay, keep going. We travel up, 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 up. And now we're at the top of a curve. So that guy, the top of the curve, high point is a maximum. That is the point 2, 1, 2, 3, 4, 5, right? 2, 5. So we put 2, 5 as our maximum. And then let's see if we have any more. Just keep traveling down, 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 down. Okay, we never switched to coming back up, so there's no more mins. Last thing is end behavior left and end behavior right. The left side of the graph is over here. So we start with this arrow. It is pointing upward, so that means that it is rising. Left arrow is rising. And then we just look at the right arrow. The right arrow is down here. It is falling because it is pointing down. Done. Not so bad. Let's take a look at number 2. Type and degree. I'll switch back to blue. Starting from the left, working towards the right. Zoom in a little bit. From the left to the right, looks like we are going down first, and then up, and then down, and then up. Down, up is 4 directions, so our degree is 4. The word used for that is quartic. Okay, I know that quadratic also kind of sounds like 4 because quad, like quadrilateral, but quad is like a square, right? A square is a quadratic. X squared, okay? Quadrilateral, square, x squared. Quartic, quarters. That's how I remember the difference when I first learned them. Okay, how many zeros are there? Where does our graph touch the x-axis? Nowhere. So you can just put the word none or not applicable or something like that. I don't want you to put the number 0 if it says how many zeros. Because if you put literally a 0, then I don't know, me, Miss Campbell, I do not know if you mean x equals 0, your graph crosses at 0, or there are none. So just use the word none and we'll call it good. Okay, min and max. Mins are lowest points, maxes are highest points. They happen every time we switch from moving down to moving up or moving up to moving down. That happens right here. Down to up. This guy is the lowest point in its little area, so it is a minimum. That happens at the point -1, 1. -1, 1. All right, let's keep going. I like just following along, and then whenever I find a min or a max, I write that one down. Here's another point. It's the highest point in its little area. It's at the point 0, 2, and since it's the highest point, that makes it a maximum, 0, 2. Keep going, move down until we get to a minimum here. That's at 1, 1. It is a minimum because it's at the bottom of a curve. So 1, 1 for minimum. And then keep traveling, and we never reach a highest point because we have an arrow going on forever. Cool. End behavior. The left and the right, both of those arrows are pointing up. So the left is rising and the right is rising. Fantastic. Last one, number 3. We're going to kind of estimate this point because it was hard to find a good graph that did exactly what we wanted. So we're going to say that this point right here is 1, 5, even though it's just a little bit off. Okay, let's start with directions and what type and degree we have. So that's how many ups and downs we have. Starting from the left, we move up. That's 1 direction. Move down, 2 directions. Move up, 3 directions, and move down 4 directions. 1, 2, 3, 4. 4 is quartic. All right, next is how many zeros. How many times does our graph cross the x-axis? It crosses 2 times. On this graph, the picture doesn't cross the x-axis at very good points. That's why we just said how many, not what are they. Okay. On number 1, we said x equals 3 because you can tell that that graph crosses the x-axis at 3 exactly. This one we would have to kind of estimate like negative 0.1 and like 1.5-ish. I don't know. So we just said how many? There are 2. There are 2 zeros. It happens at 2 spots. Mins and maxes always start on the left again. We are moving up, up, up until we get to a maximum. That maximum happens at -2, -1. Is a maximum. Okay, keep going on our picture. Down, down, down till we get to right here. That guy's got to be a minimum because it is at the bottom of a curve. -1, -3 is that point. And then from that minimum, we travel up, up, up to get to here. And we said we were estimating that point at 1, 5. It's at the top of a curve, which makes it a maximum, 1, 5. And then continue down, down, down forever. Okay, so no more mins or maxes. End behavior is the last little bit. The left and the right arrows are both pointing downward. So left and right are both falling. We will be practicing this more in a future section, so we will get better and better at identifying zeros and graph types and rising and falling and all of that stuff. Have a great day.